Okay, I think we're live. So, hello there. Welcome to another episode of Amplify F Sharp. Today, we're just gonna walk everybody through F Sharp 10, what's new, what happened. We're just gonna dive in real quick. We're hoping to catch maybe someone from the F Sharp team, and we'll just see how this goes. It's been a while for me myself personally, so I'm just gonna wing it a little bit for the folks back home. But do engage in anything you want to say. So we can have a chat, we have a converse. This is a bit of a loose session this time. I'm just going to share the screen, get kickstarted, and let's just maybe walk over the blog posts that were announced, and then we can like go over some topics over there. So let me share Google Chrome over here. There you go. First up is a bit of a public service announcement. We are considering changing some default in Phantomus. And in essence, there's like a way to format records, which we do right now. There are other ways to do it via settings. So there's this thing called cramped, there's this thing called aligned, and there's this thing called strip. And in essence, we actually want to have a conversation with the community. What should the default be? We're having a little voting system if you prefer to keep the default or aligned or stop. And it will really help us a lot if everybody involved, puts out their voice, because we just, we're changing a default that has been there since the beginning of the project, and we don't want to do this lightly. So we really want like an absolute number of votes to be, comfortable with actually doing that. So we could also draw a conclusion right now, but maybe we're just not reaching enough members of the F Sharp community to really get like an accurate vote. So yeah, we'll leave this in the comments somewhere, but please do reach out. And then for today's topic, we'll talk about announcing F Sharp 10, where we can just first go over the blog post. And we are fortunate to have Martin with us on the stream. And Martin, why don't you just dive in and talk about scope warnings?
Scoped warnings, yes. That was an interesting journey for me. Took about a year and a half, right? There was a discussion last year in June, which is actually much older, that people want this feature. This feature that means you can not only turn off warnings, but also in the same file turn it on again. And here are a few examples in the blog post that illustrate why people need and want this. If you see that first example there, uh, in that middle line here in the source code, you have you get warning 25. Um, And sometimes you just want it that way, like here where you use the deconstruction and you get an error. There might be the none case, so you shouldn't do that. But sometimes you just want to do it that way and suppress the warning. But then for the rest of the file, the warning would be very useful. So that's why we introduced this warn on directive so that you can switch the warning on again. Perhaps that's sufficient for the feature itself. Or are there any questions? Else I would dive a little bit more perhaps in the experience of doing that.
So, like as a user, like I was wondering, like, what was your primary motivation, like, to implement this? It was a personal use, or it was something that you were more interested from the technical side? Like, did this was a way to describe your each, what was your main motivation, or like?
Yeah, at the time, I was just getting into the compiler, let's say, right? I finally had time and still have, luckily, to work on open source. I accidentally came across a project that Florian did at the time, or still does. And there I learned first aspects of the compiler, found that challenging and interesting. And I've just followed the discussions in the F# repo, and there was a long and old thread about this feature where people requested it, and uh, I think it was June last year when another request of that kind came up, and the F# team said, yes, we would love this also, but we don't have the resources, but maybe we can support if there's a volunteer. And then I waited for some time for the volunteer, and then I said, why not try that, right? Which in hindsight was a bit naive, perhaps, because it turned out to be much, much bigger than I thought at the time. And yeah, now a year and a half later, it's actually in F#.
That's really wild that you just worked on this for more than a year. And, given the complexity, I get it. Like it's just that amount of work to really pull it off. But it's yeah, been following along on that, and it's just been a wild journey of how to do it and how have proper conversation of doing it. Like it's not only the technical side, it's also a lot of things you have to consider, like how do we want this to work? So yeah, amazing contribution, really.
Yeah, it started actually with defining what to do, a discussion in the repo, and then RFC and further discussions on that. And like always, when you start writing things down, more questions come up, and that was also happening there. And then um, yeah, in part it was difficult questions that we had to find solutions for. And then actually the feature is now ready for quite some time. We just had to wait for the F10 release now. That would make the year and a half. In hindsight, I must say, right now I think what I want to tackle next is not really features, but making the compiler friendlier for the developers. The compiler is has grown into a sort of monster, and I don't want to blame everybody. It's just how it goes when you have complex systems with many contributors. And I found that especially in those infrastructure layers, right? I never dive deeper into type checking or anything, but in those layers in the driver directory, everything is connected to everything, and that makes it very difficult to change stuff. And if possible, I would like to piece by piece clean up a little. One thing I came across when doing the no-warn was these line directives and how they were implemented, and I created a workaround. And only later it became clear that this needs a much better approach, and that's why after that I created a new way to deal with the line directives. And so in hindsight, I would rather work on these prerequisites than tackling such a feature, I must say. But now I'm glad it's there.
Mhm. And I guess another key takeaway, if you want to do something larger, you just have to do it, like to further explore where how you can do it and what it can be to really define it. You just have to do the work.
Absolutely.
Because
Yeah.
like there's a lot of language suggestions where conversation happens and we theorize about what could happen and all these things, but yeah, this was one you just had to bite the bullets, see where it goes, and then that's how the winner takes it all.
Yeah, and only when you start implementing, you find the questions that you have to answer.
Mm-hmm.
Yeah, one piece that I really liked was that like now editors like Ionide or VS Code or Writer that are now like they have this hub feature like available at least like I think Ionide already has it I think and Writer is adding support for this in the repo as well. So we will have this at some point like we will have editor support for this.
Yeah, I should also mention, of course, that we had to introduce a few breaking changes in compatibilities. A few of them even visible to end users, but certainly breaking changes for the tooling But with the current state of the compiler, it's very difficult not to do that.
Mm.
Thank you,
Yeah.
Martin. Yeah, it's good.
Yeah, thank you.
Yeah,
All
this
right.
I just want to add, like, this is just a wonderful feature. This is so nice, specifically for very, very dangerous things that you know are like safe. And I'm gonna be using this very heavily.
Oh, nice. I assume this is useful for library code where you like you know what you're doing, but then you just wanna.
Yeah, there's just some types of warnings that are like a little bit more handholdy than you'd expect. And this will be one of the things that's just like, no, 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 the serious, like, specifically like resumable code for a while had like warnings that it's like, hey, you shouldn't be using resumable code. This is a weird feature. It's like, no, but like I can turn that off at the high level, but like there's a lot of warnings that are kind of like that, where it's like, I know this is kind of a preview feature. I can use this. It's fine.
Mm-mm.
Stop nagging me.
Maybe
But I love this. I love this. This is such a great thing to have.
there's a new warning about the statically type task. What was it? Like that most people are ignoring now, like on their like on the solution. So maybe this will be a way to disable that or like ignore that
Yeah.
warning.
Yeah, that's another warning that can be annoying for various reasons. Maybe we'll fix that in some other thing eventually, but that'll be maybe after if we read through this blog post.
Maybe.
All right, let's move on to the next. So access modifier on auto property accessors. I'm a little less familiar what this one is about, but it's about properties with backing fields where you used to have an actual instance declared and afterwards you don't. That's my brief understanding where public get set just works. But if you, yeah, the fact that this one's public, this one's private, this works now, and before you probably needed an actual backing field yourself, as
Exactly.
far
Yeah.
as I can tell. Yeah.
Yeah, exactly. It's a way to give you, all the granularity to define different access modifiers on gets and sets, and kind of also reduces the extra boilerplate for you to play that. This was external contribution as well, just to give the full context.
Mhm.
Yeah, this was don't remember his name, but yeah, it was external contribution.
Yeah, I think that was really like a totally new contributor, right? That's
Yeah, I believe so.
someone that came out of nowhere and just like implemented this very strongly from the start. Um, so yeah, I mean, we didn't have any hand in it, but I do kind of feel like we're allowed to take some credit. Maybe we inspired that person. Maybe, who knows?
Maybe, who knows? Yeah, and there's also some caveats about like this one doesn't work with signature files for maybe some obvious reason that I cannot think now. But yeah, there's this. I think this won't be able to be used with a when you define a signature file.
Mhm.
You need to have
That
the
that
proper.
that 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 rings a bell that there is a little bit of gap in terms of what syntactically is possible with these things in signature files and it's not. So maybe that was related. All right. Value option with optional parameters. Mm, Sounds like some allocation improvement here, where we're avoiding some, which adds a new struct attribute. Jimmy, does that one ring a bell?
It doesn't ring a bell, but it's not surprising as a addition. This is something that a lot of people are trying to push into F Sharp, is just being able to use more of the struct features in places that our option was. And this does help with allocation pressure, because even though allocations on GC0 are relatively short-lived and not a problem for many applications, the allocations are still allocations, and you should try to eliminate them as much as possible. And I'm definitely happy for this.
Yeah, I see this as a like a feature parity or something like where like we have value options on like in F sharp now struct. So it is a way to not feel the user won't be surprised if they cannot pass a like a struct as an argument there. So yeah, there's
Same with like pattern matching. Pattern matching has had this like struct availability for a while. Like this is just another nice addition to the general value option changes, which I think is a corresponding thing that's not mentioned in this blog post, but there was some fixes in the .NET 10 runtime around the value options specifically, because there was something that the JIT wasn't working with the value option as well and actually causing performance degradation. And I think in 10, value options are a lot more valuable now, as you probably won't see the performance impacts if you were measuring for specific things. I have to go find that exact issue, but I think there's a very specific like thing that makes value options way more enticing to use now.
Right. Moving on, tail call supported computation expressions. That also sounds very complicated and
yeah.
well, impressive to like nail down. So, Jimmy.
Yeah, so I don't know exactly how I'm going to implement this feature, but this is something that's been like, so in the resumable code space, there's been this like missing feature set where like there's no way to kind of know if something is a tail call recursive without doing some extra work. And so this is put into the compiler now. The examples here are a little light. The code that originally had this kind of implementation details shows how to kind of go about it. So you'd have to actually look in the F# compiler for this coroutine code to kind of see how resumable would prove out in the coroutine. But this kind of change will make it possible to do tail recursion. Now, that being said, I don't know exactly how that's going to play out in libraries like IceTasks or the async seek compute or task seek computation. I still haven't played with it enough to know all the finer details about this particular thing, but I'm glad that this is here at least where I can start using it.
It also reminds me a little bit of the tail call, tail call catch feature. Like I don't really know if it's an attribute or how that really works, but there's something you can do and then it checks if your function is, tail recursive or not.
Yep,
Will that
David
also
made that a
exactly
few years ago. I'm not sure which release that came out in, but yeah, there's a tail recall attribute you can apply to functions that will force it to be tail recursive, or at least check at compile time. You can't get it during editor time, unfortunately. It's only a compile time check. I don't know how that'll play with this, but
Yeah,
like I said, I haven't played with enough. I will definitely test it though when I get to it.
Yeah, I'm also curious indeed if that, somehow related or if that same check can post inference or
depending on how
just
it's implemented, I'm not sure, because like normally the recursion happens with an actual like tail call in the IL. I'm not sure how this is being written out in terms of the IL. So again, like I don't know full details.
So I say like let's say I have someone reading this like there is now two reserved member names. So the return from final and the yield from final are things that you will need to implement in your computation expression to
yeah.
be able to get the benefits from this. So
Yep.
like
And
you have your bind, your merge sources, combine, run, all of that stuff. So you will need to implement those two. And I guess it will be a breaking change if you already have some members that define that have this name, or you won't be able to use this. I don't know if that's
yeah, I'd say it's very unlikely someone already wrote these with these names. It's maybe someone has before, like very custom functions for a CE, but I can't imagine there being people who wrote resumable code with custom CE functions that had this. Like maybe someone did, but this feels like a breaking change. That's fine.
yeah. Cool. Yeah, sounds good. This was implemented by external contributor again. So yeah, he's very active, and we are lucky to have him around.
Nice. Oh, yeah, they don't seem to mention the names here, but there probably is going to be like a little thank you section at the end of this post. So we can see some names over there. Okay, next one, Edgar, I'm going to look at you. You did something here, man.
Yeah, this contribution came out of a frustration, to be honest, because I wanted to add a type annotation to a lead bank when I was, were my working hours, and I was like, oh, why cannot just add a type annotation? So I realized that you need to wrap it in parentheses to be able to put any type annotation, which is different, or is not consistent with a normal lead bind that you can just basically, you don't need anything like that. So I was like, okay, so how can I fix this? And it wasn't any type checking issue or anything like that. It was mostly that the parser did not, it wasn't really covering that specific case. It wasn't doing some error recovery there. And then, the rules between let and were also two different rules. So yeah, I had to do some changes in the parser. It was a lot of work, a lot of try error, try error, try error, and yeah, a lot of reviews from the compiler team, from Eugene from JetBrains as well. Yep, so it got to the state where now we no longer need a parentheses to add type annotations on let bang or and bang, and not even, I think, also use bang will also had to have I think a parenthesis as well. I'm not sure, but anyway, this is now all consistent, all like uniform, and then you don't need to have like worry about that. And hopefully the tooling will catch up. Let's say in a way that there we have a parenthesis analyzer that will be able to maybe at some point be updated to remove the parentheses that were added before this was implemented. And also we can also maybe add support for the quick fix that we have that says add type annotation to also work with leadbang now, because I don't think it worked with leadbang so far. So yeah, this contribution opens a lot of nice things on the editor side as well.
Yeah, like you said, there's a thing you see here which end users can now just type in now that works. So that's definitely good. But you also did a lot of cleanup when it comes to like the syntax tree, and there's a lot of streamlining and unification between all these things. So I'm actually currently working on, getting support for this new syntax in Phantomus, and a lot of things are just like improvements and code cleanup just because how, much more streamlined all of this is now. So yeah, happy on my end as well for that. Good change.
Good. That's okay though.
All right, so now we have allow underscore in use bindings.
Yeah, I did implement this as well. And essentially, there is the difference between use and the use ban. And I was like, why, why cannot add just an underscore on a use ban? And I was like, this is nonsense. What's going on here? And it was the same. The parser, it was there were not really much changes to be done in the parser. It was just when we were doing the check expression, and then we were checking the head pattern on the expression. There was some we weren't considering that specific case. We had the analysis for the parentheses, but not for only the underscore. So it was just basically two lines of change, and we have this now where you're able to just type underscore to that. Before you had to do, I think it will be underscore underscore or underscore underscore and extra identifier. So it was kind of a little bit of a inconsistency there, but now that's no longer the case. You can do underscore on use and a use bang as well.
I mean that sounds like on a technical level, this is a synpat wildcard or something, and
Mhm.
then multiple underscores somehow are an ident, and because ident has an internal name, that was why it was working, and you probably did some magic to get this into like a fake ident somewhere in the
Yes.
compiler.
Exactly. Yeah, it's been almost a year since I did this, to be honest. I haven't really go back and check that. But yeah, exactly what you mentioned, that rings a bell now.
Mm.
Yeah, this is super great. I love that. The annoyance of having to have an identifier on things was grating.
Mm. All right, next one is rejecting pseudo-nested modules and types. So in F sharp, you can't have modules inside of a type, which makes sense. Maybe that's a thing in OCaml, but I don't really think that either. So yeah, it's like misleading if this silently fails when it's never allowed in the first place. And now we get like a proper warning just to like force you to, move this up so it's clearly outside of the type. Yeah, I think this is just really another quality of life for newcomers or something who don't really know that this is an established thing. It now really, has a proper code and guides them towards their intent.
Yeah, from the technical side, like I did implement this because Brian, which well, we know from the community, had this like I found this like found well like I think one of his work colleagues basically found this or something, and he was like, this shouldn't be happening, right? So like the I had to first add a warning on the parser level and then like ask for review, and I think yeah, I was giving them more guidance that they shouldn't be in the parser but should be more in the lex filter where we know the indentation it's the indentation context I think is more clear there. So yeah, it was actually yeah not difficult to implement, and the benefits are a lot because this is a error that is recoverable, so it's not going to like let's say destroy the analysis of the code that is the valid code. So it will only raise a warning or sorry an error for that specific code, and it won't really try to type check anything, or it won't try to generate IL or anything like that for this.
Hmm. Yeah, makes a lot of sense. All right, and another wonderful legacy thing which is no longer allowed, the uh, the weird secret syntax. I don't think I've ever seen this in the wild, but historically you're allowed to create like a sequence with the syntax without just anything. And I guess pretty early in the F Sharp's career, this computation expression builder came, but yeah, we no longer have the implicit sequence.
Yeah. Again, it was something that I found very annoying that like you can have the like you will have to really there was a implicit consequence construction on the first example, and then you had to add that there. So like okay, how can I raise a warning and now to be able to say please use seek keyword plus that. And then, like, yeah, I was able to implement this and add a quick fix to Rider, which I think is live now. I think I still have to finish the IONI one. I'm not sure if it's still, if I did implement that or not, but I will try and, if it's not, I will try and close the loop there to be able to have a quick fix for you to add this seek keyword in front of your stuff.
Mhm. Then another wonderful talking point. Edgar, attributes, the bane of your existence. Go for it.
Yeah, okay, let me go in a small rant about this one. So in hindsight, I think the way that the interaction between attribute targets and the F sharp and the F sharp compiler or the F sharp code is being always hasn't been documented. You have some expectations when you use them in C sharp, and there's a different language difference between of the constructs of one to the other, but essentially these were not enforced at all in the past. There were like some like enforcements, I guess, maybe let's say 20% enforcement, but the rest it was just like there was nothing. So and this specific example kind of was brought to my attention that if you use I think it was XUnit, yeah, I think it's XUnit. But basically, if you try to use that fact attribute on a value, which is the first line, it complain, but the underlining detail is that fact is a attribute that can only be using a function, so it shouldn't be able to use it on a value. And what happens is that all of your tests that were like the first example will silently being ignored. So you will be thinking that you have code in production that's been tested and everything works fine, but in reality, all your tests are essentially broken and are being ignored. So these will essentially, make sure that at least for that specific scenario, if you're trying to use an attribute that needs to be enforced on a function, is not going to be used in other places. So these will, I think, it even brought 5 or 6 unit tests on the compiler that that they were like ignored as such, which is like a pitfall of like thinking that you are testing your code and it's not being tested. So this was my initial, let's say, use case for that. But then I went into rabbit hole because now functions, okay, but what about return types? What about class? What about records? What about discriminated unions? What about interfaces, delegates, and all that stuff? So it was like a rabbit hole that I had to go every single um, case. And I think overall, the quality of the interaction between attributes and F# are better now. But there are still some, like maybe scenarios where people are still relying to the attribute to work in the wrong way. But I think it is so difficult to make them update their code just for these scenarios. So I think we did something where there's a specific scenario when you're trying to apply this on a union case, in a union case that we had to basically roll back that specific fix and have a extra warning or extra error, sorry, to basically say if you really want to analyze the interaction between union cases and attributes, you need to basically enable all these warnings so you can get the full analysis. Otherwise, we are ignoring that for now to not really break everyone with that.
Yeah, I mean, this is a classic case of something that's always been a little bit, gray area, and then you're trying to fix it, and then certain things sort of rely on the gray area, and then there's like find middle ground, but also try and be more strict. But you can't be too strict because, yeah, if everyone needs to update their code, and that's a bit of a pain. So finding
Yeah.
balance there is a tricky one.
I felt like a bit bad going, I think at some point in F#9, because this was supposed to be in F#9, but it was rolled back to preview, and then I had to like fix some stuff to make it, releasable again. And there was a lot of like, I just compiled my library with F#9 and .NET 9, but now I'm getting this error. And like, yeah, this code base is no longer going to be receiving updates, so I cannot really change my code. So they were like, even in Microsoft internal, I think there was some library that was relying on .NET Framework or something like that that couldn't really receive any updates or something like that. So yeah, I imagine some of the actual users would receive this, but the intention with this was to make the enforcement more the attribute to be more enforced, which is I think a bigger benefit than just updating your code. But I can understand the other way around as well.
Yeah, I mean, the intention, if you look at this example, this is, a very clear case where this is so valuable to have. But yeah, you went down a rabbit hole because a lot of things were gray area, and then, yeah, difficult stuff, of course. But, nonetheless, thank you for all your hard work and for keeping up with that, because like you said, this has been an ongoing effort since F# 9, and now we're in 10, so you got it across. Well done. And this one caught me a little bit off guard. I kind of assumed that this was the thing and it was always working. So
Nope. So this has been a pitfall or a rabbit hole that you can go down of like ivory tower discussions. But basically the idea here is, yeah, you can like F# has had the applicative and bang thing for a little while, since like F# 5 or something. It's been quite a while. And it's used in terms of being able to write parallel computation expression stuff. Parallel doesn't mean like running at the same time in that context. It just means that like two operations could potentially not conflict with each other. And so like if if you're thinking like a result, you'd say like, hey, I want to verify that, my name is a certain amount of length and is, I don't know, not null or something. But you would check both. You could check both at the same time, and they're not strictly like very or like uh, being a problem with each other. But people have wanted to say, hey, I want to be able to use this in other parallel contexts. And in the case of async, this has been a discussion point that's been around for a while. People don't. There's technical reasons why you may not want to use and bang in async. But in tasks, the idea is that, yeah, we could have two things running at the same time. And the and bang keyword seems to be a perfect good fit because there's really no like there's some things on the async side that's some technical reasons why you might want to not use it. But there's specifically in the tasks, there's really no reason you shouldn't be able to have this. I've had this implemented in ICE tasks for quite a while, and it's finally basically made its way up to F# core itself, and which is a good thing to have, because doing that kind of explicit combinator stuff, very annoying, very, very tedious. I think there's still some like nice things that can happen eventually with changes like moving the stuff up to F# core, but the basically what I want to say is just like, I think this is one of these cases that something that has been living in a library code should have been moved up into F# core, and this is definitely one of the cases that it should be there. And if you want parallel async, IceTasks has a parallel async computation expression that supplants if you want to go look for the arguments of why we don't have async or and bang and async computation expressions, you can go find that discussion and watch the ivory tower fight each other.
This plays nicely with the changes on the parser about type annotations without parentheses, because like those pieces were done for everything, for every construct, not only for one case.
Yes, they do. Now, also, I do want to mention this is still because task semantics are different than async semantics. I just want to outline that, or lay this out. Whenever you do run a task, it doesn't necessarily mean it's going to run on another thread immediately. And so doing this means that you're assuming that fetch A and fetch B are both going to like actually do async work, because you can say, hey, I'm returning a task, but I could just have a while loop that's true and just never return. So there may be a possibility that this actually doesn't run concurrently at the same time. But that's still like, that's just standard task semantics. So I just want to make, I have to point that out all the time when it's like, oh, we're on these two things at once. It's like, nah, task semantics are weird. They're very annoying, but they're consistent. They're consistently annoying, but they're annoying.
All right. Performance and tooling. The type subsumption cache. Can anyone tell me, is that what I think it is? Is it a sort of cache that when you did the initial compile, it can be reused in incremental compilers?
From what I remember reading about this, there basically like this is one of those caches that when you have it says complex type hierarchies, like this is basically used for the case of like interfaces with what's the IWASM stuff or IWSM.
Public abstract interfaces or
Yeah,
something.
public abstract interfaces. And so because .NET introduced like a billion interfaces, like 2 versions ago, F# had to like have a better type hierarchy thing. But because there was just a ton of those interfaces, there was leaks in how the caching worked. And so it could like your compilation got really bad all of a sudden in like F# 8 or 9. I forget when they released the .NET released the public abstract interface thing. And this is just further work on making that better.
Yeah, because that's probably about like base library and some other NuGet packages, which has a bunch of stuff which you kind of know if you're going to compile again, we'll need to get all the hierarchies and all the interfaces somewhere in type tree information, and that probably is what they're trying to cache, right?
Yeah, yeah. It's just that giant because like you can have like an integer now has like I number and I addable and I subtractable and like why does my integer have 100 interfaces? Because reasons.
Reasons, math,
This,
why
yeah, it's important to say that this was, I think at the beginning was implemented by Vlad from the F# team, only within the within the compiler itself, but it didn't have any support for IDE. It wasn't really exposed to the tooling. I think so. Then a external contribution came and just basically reused that, fixed a little bit that they were not, doable for the IDE, and then kind of now I think it's an option in Visual Studio, or there's an option that you basically can enable this on your editor. Yeah, but this is now being streamlined to the overall editor experience by external contributor.
Do you happen to know the setting for that? It's probably something we need to actually mirror cyanide, and I probably did not do this.
I will look for the PR. Let me look for the
Okay,
PR on the website. See if
thanks.
I can
Yeah,
find it.
send that my way or create an issue on
That's
FSAC.
yeah, that's my understanding. I mean, maybe it's not, but I remember like there's this being says that because it's an IDE feature, you can basically toggle it. But yeah, I will make sure I clarify that.
Yeah, I don't know
So
if it's on by default with like a fine number, then I might not add a setting immediately. But like because sometimes it's just like, hey, we have a setting now that you can, control the cache value, whatever that range is. It's like maybe I'll add that, but it might not be a big deal.
so
But if
this
it's not on by default,
might be like a setting to the F# checker then, or
yeah, I don't know. That's the thing. Is like sometimes this is an environment variable, sometimes this is a parameter, sometimes it's the value you set somewhere else. I don't know. It's all those are kind of all over the place.
yeah.
Some or a
Mood
property you set in MSBuild or whatever, right?
mood of the day is real, like, just
Yeah.
gotta flow with it. Yeah. All right, moving on. Better trimming by default. I've never really done much trimming, and I think that's partially because I do like more .NET tools, which you then ship on NuGet, where trimming isn't really a thing because you don't really know whose it's for. So, does
Yeah.
anyone?
It depends on what you're shipping. Like specifically, Phantomus as a CLI tool could use this. Like this could be usable for the CLI tool experience, and same with analyzers. Anything that's kind of analyzers won't have as much better trimming because there's a lot of reflection magic to load analyzers, so that probably won't be trimmable. But like Phantomus could probably utilize something like this.
But do you still need to know like your target operating system? Like if you're trimming for Linux or Mac or one of these things, right?
So good news, F Sharp 10 or not .NET 10 allows you to also have your published targets for specific architectures and operating systems. So you can ship individual packages. I don't know exactly all the details of that. We'd have to have Chet on to explain all that. But the idea is you could target specific operating systems and trim specifically for them and build in like there's multiple aspects there. There's like trimming your binary, and then there's also like packaging it so it can be run like self-contained. So like those are distinct things. But the trimming aspect is just like being like, hey, I don't need all this extra stuff in my deal. I don't, F Sharp Core has a pile of functions. I use 10% of them. I don't need all these. Let me just remove it. But the self-contained stuff could also be. But so like there's this is part of that like ongoing effort in .NET to just be able to make binaries like pretty small, and not be like, hey, look at my C++ binary, it's 7 kilobytes or whatever. And then like .NET, you're like, why is my binary 700 megabytes? It's like, because I'm shipping the whole runtime. Like I don't, something's wrong.
Yeah, it's nice. It's really something to look into, and definitely the .NET 10 thing as a whole, it does ring a bell. Like you can do more efficient stuff now. I think with Phantomus, certain formatting really was a lot better if you just target like the single file, go pretty native for certain operating system. Then there's like a lot of ground still to cover there.
Yeah, it's one of those. It could be useful, but it's not like I think it depends on what the overhead is, right? And like startup time. If our application startup time and shipping is like, a couple milliseconds, it's like, well, whatever, maybe it's not worth developer effort. But if if it saves, lots of megabytes, maybe that's worth it. But because also the aspect of shipping your DLL with a specific runtime might also have some knock-on effects. So like, are you runtime specific? Like, I don't think Phantomus is, but like for instance, FS Autocomplete is runtime dependent, and it would be nice to be able to ship specifically for runtimes as well as operating systems.
Okay. All right. Next topic. One personal interest, parallel compilation. So these are like multiple parallel features. The first one, graph-based type checking, something I worked on a couple of years ago. It's like a sponsored effort from the good people of G Research. Then there's parallel IL code generation, and there's parallel optimization. So these are all community driven, I think. And the nice thing is for .NET 11, they're actually already enabled by default. So we're getting there. You can put this in preview today, although there's a little bit of false advertisement. I am going to point that out. If you do graph-based type checking, you should have deterministic false, and that's enabled by default. So those two don't work together. And then you think you put on parallel compilation, but actually you're going to miss out one of the three. So that is something to point out. But nonetheless, I mean, try these things. If you have a certain size of a project, it really can make a difference for your compilation time. And yeah, the more efforts we do this, the leaner the compiler can get.
So I sent something in the Zoom chat. You'll want to click on the link. It's basically showing how you might want to approach being able to make your graph a little bit more graph friendly. Because turning on the graph mode doesn't necessarily mean it's going to actually be faster. You might have to actually do some work in your application. And so here's a pull request that I did specifically this, where you can see that the ICE tasks graph this is basically what it looks like when it's completely sequential. Everything references each other. It's very gross. Worst case scenario. And it's like, okay, what happens when I actually do turn it on to be more graph based? And unfortunately, the mermaid diagrams are still kind of like, I had to take pictures of the mermaid diagrams. And so this is what it would look like in a real graph-based scenario. And this looks a lot more clean. Unfortunately, for other reasons, this didn't speed up as much as I would hope, but this is like an approach that you can utilize as a way, like you can reference this as a way to potentially see why, if your graph is very sequential, how do I turn it into actually utilizing the graph-based stuff.
Yeah, plus what you see here, like task-like.fs is a very good candidate to try a signature file, depending on what you do in that file. If it's not too much, if you're only exposing a couple of functions, then a signature, just immediately unblocks all the other files, sticking in the compilation in parallel. So yeah, there are definitely considerations. But last thing I remember there is that it's counterintuitive. Like sometimes adding an interface file for this cannot necessarily, could potentially not have the speed up you hope it does have. While adding something for another file could. So it was definitely a bit of an interesting experiment there.
Yeah, like there's another. I need to really update this, but let me try to send you this as well. But I do have a gist where I have some like F# script that you can kind of utilize to be able to get like, hey, this is like the best way to kind of go about it with some pointers. Let me see if I can find that real quick. Graph-based parser. Yeah, so here I'll send this in the chat as well. So this is kind of this might need to be updated a little bit. I haven't used it in a little bit. But the general idea here is it will, whenever you turn on the graph-based type checking, you can also turn on getting the times about what took the longest and like the actual graph, which is that dump checking graph, which will dump a Mermaid file, and this will parse both of those. And then you can kind of see like you can use this as a way to spot bottlenecks. And then you could potentially then be like, okay, yeah, so like as Florian pointed out, hey, that one file, everything's pointed to that. How big is that file? If that file is really large and really only exposes 3 functions, a signature file sounds perfect for that. And so this is kind of just like a way to kind of go through this and be like, what am I doing? Say like, who should like, why are things relying on each other? Maybe I should break up certain files. That too. Like this is also a way to kind of help you analyze that stuff.
Yeah, exactly. I mean, it's just a little bit trial and error. Look at the timings. Even if you add a signature file, there's also a cost of, checking is the signature file really, in sync with my implementation. So you need to be aware of that. If you put a signature file for absolutely everything, well, then a lot more can happen in parallel, but a lot more needs to happen to verify that all the signatures are correct. So yeah, it's definitely a bit of trial and error. But circling back to like the main idea of the graph-based type checking, if this works good enough, in theory, we could potentially not have the file order anymore in in your FSProj file. Like if this works really well enough, it could be like how OCaml does it. OCaml has the same rules in F#, like you can't use a function before it was defined, but you don't need to specify the order. It does that via the untyped tree, and it has similar mechanics. And yeah, the better this gets if this is able to really properly get all the entire graph of every project in F#, then it opens just a lot of other doors. And yeah, so really do try that out. If you do see something weird, please report it to the team. Yeah, it would be great if more stuff can happen with that. All right. This next one, type check only mode for scripts, also is like a very interesting one because when you use like NuGet references in a script and you don't specify versions that strictly, then in essence, if you don't touch an F# script for like 6 months, it's a bit of a gamble. Will it still really work? And I believe this type check only really is going to process your scripts, do all the checking, and not actually run it. So like in a CI scenario, that's just really valuable.
This is something I poked Thomas about, and he like apparently lit a fire under him. as well, because this got implemented like relatively immediately, and this is something I'm looking forward to. This is something that's really big for my team. We use a lot of scripts for helping stuff, and then yeah, so you're right. It's like some things like that file hasn't been touched in 6 months, and we had a reference to this, and that API doesn't even exist the way you think it does anymore, and so you got to go back and figure out which NuGet package had that version and blah blah blah. This would just add so much help to figuring out like which scripts are broken. Because also you can touch scripts that implement or reference other scripts, and you might break other scripts and you don't know. So there's also that, which is kind of what the next part is talking about, where it doesn't check, it only checks the first loaded source, and it's like we need to check multiple. So
Mm. Yeah, but still, I mean, start somewhere. Like there are more scripts probably just one file based versus scripts that start depending on each other, and that's a little less common. So it's definitely it's good that the limitation is mentioned, but it's not the end of the world. This will be useful for a lot of people right at the bat, so it's good. Okay, moving on, and then wonderful thanks and acknowledgement. So 25 different contributors, and yeah, this F# 10 really would not be F# 10 without all these efforts. The F# team, does a lot of good work as well, but they're a little bit reduced in numbers. I think that's fair to say publicly. And yeah, without external contributions like this, not the release notes wouldn't have been that long, and we can only give our heartfelt thank you to everybody involved.
Yeah, definitely, especially a special shout out to Jacob, which is known by Mahoka. Yeah, it's been a very, very like interesting couple of maybe 6 months a year where he was consistently improving the performance on the compiler itself, on the editor, on like a type checking with the caching, and
And a
he
lot on testing. Yeah.
testing as well, and we even sponsor him for a huge speed up in computation expression that I think will be available in F#, maybe 10 point something or 11 for sure. I put the link on the chat if you want to click it, Florian, which is the first one.
Yeah, got it.
And yeah, I don't really know much about this, but I've seen the benchmarks and seeing the reactions, and think it's going to improve a lot when you work with deeply nested computation expressions and all of that.
Yeah, I mean, just look at this test going from 1 second to 350 milliseconds. It's just wild.
Yeah.
yeah, specifically around like resumable stuff, this is a big, huge win.
Yeah, I mean, and Jakub really, talented engineer and does very, deep dive kind of PRs and such wonderful stuff. It's really that kind of people are just a blessing to have in the community. And then Martin, which we all know and love with the Nowarn, and yeah, very wonderful stuff. And then our beloved Edgar got mentioned here. So thank you, Edgar, for everything in F# 10.
Yeah, it's been fourth in a row, so I think this is an achievement, like for me, fourth in a row. But yeah, I'm going to slow down, just letting everyone know that life is catching up to me. So I need to do some real life stuff. So yeah, I will be slowing down. So now is your time. If you're listening to this and you're curious and you like doing things, not waiting for people to do things for you, just follow these examples and reach out for help or for anything. I will be happy to help you to be the next Edgar or the next Martin, or just try to help rather than just complain.
Well said. And then, of course, the people from JetBrain, Eugene and Alex are still, heavily involved in all these tooling and partial recoveries and fixes. So it's wonderful to see that they as well get to do get the bandwidth to do all these contributions. So it is, yeah, just wonderful to see that, these are ongoing effort has been happening for years, and that's really nothing to take for granted at all.
Yeah, definitely. We're lucky to have them. Like every contribution that they do is like, focus and is like, to improve rider and to overall improve the maintenance and the make the AST ID friendly. Like, and so you could use it for better quick fixes, better experience.
All right, and last but not least, we also got a little shout out, so thanks for that as well. And yeah, I don't know, that sounds maybe like a fitting point to just wrap it up.
Yep.
I think that was it for this year. We probably won't have a session anymore, and we'll let you know after the cold winter when we return and what's up with that.
Say I might try to run a session on specifically the ICE tasks support with the runtime asyncs that came out in .NET 10. That might be a session I have somewhere, but it might go to January just because between now and the 1st of January it's a lot of holidays in the States.
Got it. All right, everyone. Thank you all for joining or watching this session, and enjoy .NET 10. Goodbye.